Hi, in this video, we will go through the common exam question in Form 4 Chapter 7, that is the acid and base chapter. So we have these three major parts today. In this video, we are going to go through explanation, calculation, and experiment. Of course, this video doesn't include everything in this chapter, but the important parts is out here. So let's look at the first part, explanation. So you got to know how to explain between the difference between acid and base in terms of their strength. So strength means it can be a strong or it can be a weak acid or alkali. So that means you have to be able to explain the difference between a strong acid, weak acid, or the difference between strong alkali and weak alkali. Then the next thing we are going to explain is the basicity of acid. What is basicity of acid? Basicity of acid means mono or diprotic acid. Monoprotic or diprotic acid. Okay, the difference between them. And then the next one is the role of water. The role of water in showing acidic or alkaline properties. Okay, that means with the presence of water, with water or without water. With water, what is the difference? Without water, what happens? Last one, acid test. So acid test means how can you test acid? That means you want to know whether this chemical substance is acid or not. What is the chemical test that you can do? Okay, chemical test. Now, this page number 1. Okay, first explanation question. So it gives you this table. It shows that there is hydrochloric acid and sulfuric acid. So you can see that their concentration is the same, but they have different pH values. So you got to explain why. With the same concentration, the pH will be different. So that means you have to be able to explain the difference between hydrochloric and sulfuric acid. So what is the difference between these two acids? Ask yourself. A few seconds. Okay. Some people might think that, oh, hydrochloric acid and sulfuric acid is a strong and weak acid. Some people might think that sulfuric acid is strong and weak acid is the hydrochloric acid. But your answer will be wrong. It is wrong. Because hydrochloric acid or sulfuric acid, they are both strong acid. What are the examples of strong acid? Strong acid, we have HCl, HNO3, and H2SO4. They are all strong acid. So what is the difference between HCl and H2SO4? If they are both strong acid, what is the difference? You can see one comes with only one H, but H2SO4 comes with two H. So this is the one that you got to explain the difference between mono and diprotic acid. Okay, so you can see that diprotic acid has more hydrogen. When it has more hydrogen ion, the pH will be lower. So what do we have to write for our answer? So first, you have to tell the difference between the acid. One is mono, another is diprotic. If it is a 3 marks question, you will only get 1 mark for this point, HCl and H2SO4. After that, you got to explain what is the difference between mono and di. So just now we have told the difference. HCl is mono, sulfuric acid is di. Now we are going to explain what is the difference between mono and di. So mono and di. H2SO4 ionizes completely in water and then produce twice the concentration of hydrogen ion than HCl. So the most important points here is produce twice the concentration of hydrogen ion. Of course, you can always change your sentence to double concentration of hydrogen ion or any other words or term that means double, okay, as long as it's the same meaning. So because of it has double, it has 2 times of hydrogen ion, that's why the higher the concentration of H plus, the lower the pH value. So again, the whole thing got to explain the difference in acid, mono, and di. And then what is the difference between mono and di? So this one got double H plus. And then when mono has 1, di has 2, you can tell the relationship of more H plus, lower pH value. So for most of the explanation, we always end it with higher concentration of hydrogen ion, lower pH value. As long as they want you to explain about pH value, this is what you can do. Next question. Hydrochloric acid, ethanoic acid, again, same concentration, but they are having a different pH value. So what is the difference between hydrochloric and ethanoic acid? Obviously, one is strong, another is weak. Strong and weak. So this is explaining about strength. Just now, this question was about basicity of acid. And now this question is the strength of acid. So first, we tell the difference between the acid. HCl, as I did, okay, let me change the color. So HCl is a strong acid. And then ethanoic acid is a weak acid. And then you explain the difference between strong and weak acid. So what is a strong acid? Strong acid is the acid that ionizes completely in water, producing high concentration of H plus. So if you are able to tell the difference between the acid, strong, HCl is strong, ethanoic acid is weak, you will actually get 1 mark for this point. And then point 2 and point 3, if you are able to tell strong acid ionizes completely in water, producing high concentration of H plus, you get 1 mark over here. And then you are able to, if you are able to explain the difference between if you are able to explain what is weak acid ionize partially, low concentration of H plus, you get another 1 mark here. So one is completely, another is partially. Last point, same point as the one just now. Relationship. Higher the concentration of H plus, the lower the pH value. Okay, I hope everybody can understand the meaning of ionizes partially and completely. Completely means if I put 10 acid, let's say 10 HCl into the acid, I will end up getting 10 H plus completely. This is what it means by completely. Partially is when I put 10 acid, maybe I only get back 1 H plus. This is called ionizes partially. Ionize is like dissolve. Okay, so just like that. And then this question I skip because it is the same. Just that you change sodium hydroxide to a strong alkali, and this is a weak alkali. Strong alkali ionizes completely, and this one is partially. And then ionizes completely has higher concentration of OH, but partially has lower concentration of OH negative. So in the end, the conclusion, the relationship is the higher the concentration of OH minus, the higher the pH value. just like that. So that's the explanation for strength. Next question. So when you see the question, they give you something like this: hydrogen chloride gas into solvent A and solvent B. When you see the word solvent, your answer will always be either water or one example of organic solvent. Let's say my favorite is methylbenzene. So when I see solvent, my answer must be water or methylbenzene. Now they ask me, name solvent A and B. So when I look at the result, it shows that blue turns red. Blue turns red means there is acidic property. So acidic properties, just now we said there are three types of explanation: basicity, strength, and one more, role of water, which is about acidic or alkaline properties. If this one has acidic properties, it means my solvent A will be water. And then solvent B, which doesn't have any change. No change means no acidic property. No property means it is an organic solvent. Why? Because acid or alkali there need water to ionize themselves. Okay, so this is why if you see property, water, no property will be the organic solvent. Now we are going to explain what is the difference between water and methylbenzene, which is difference between solvent A and B. What happens when you dissolve hydrogen chloride gas into solvent A, okay, in the solvent A or in the water, it ionizes to produce hydrogen ion. As long as you are able to tell ionize to produce hydrogen ion. Actually, in this chapter, most of the question is about ionize, got ion or not. Point 4. So this is what happens in the solvent A. In the solvent B, HCl, your hydrogen chloride, remain as neutral molecule. That means they cannot ionize. Cannot ionize. When it cannot ionize, then what happens? No hydrogen ion. So therefore, the one that has hydrogen ion will show acidic property. So it changed the color of litmus paper. And this one, which is still a neutral molecule and no ion, no H plus ion, then there is no acidic property. Just like that. Next, this is the acid test. So there are two chemical tests for acid. So what are the chemical tests for acid? We can use metal to react with acid. So one example, let's say I use zinc to react with HCl. Zinc plus HCl will get you ZnCl2 plus H2. This reaction is going to release hydrogen gas. Okay, so here, how do I know that a colorless solution is acid or not? So this is what you do. First, you add 5 grams of reactive metal, zinc, magnesium, or aluminium, it can also be calcium, into a test tube containing 5 cm cube of the colorless solution. So remember to mention the amount. And then what happens? You go to test the presence of hydrogen gas. So you got to place a burning wooden splinter at the mouth of the test tube. This is your test tube. You place it at the mouth of the test tube. And then if there is hydrogen gas, what happens? There will be a pop sound. And the pop sound will prove the presence of acid. If you hear a pop sound, then the solution will be an acid. So this is how you test whether a solution is acid or not. You put reactive metal in, and if the reaction produces hydrogen gas, it will be an acid. Why? Because according to a normal displacement reaction, let's say Zn plus CuCl2, this is not an acid. If it is not an acid, the displacement reaction will produce a metal. When the reactive metal displaces the hydrogen ion, that's why it will always produce the hydrogen gas. This is why by testing the hydrogen gas, you will be able to tell whether the solution is acid or not. Next, the second test is by using metal carbonate. With the acid. So let's say calcium carbonate with hydrochloric acid is going to get me CaCl2, H2O, and CO2. So in this case, same, I'm going to test for the gas. I'm going to test carbon dioxide gas. Same steps, you add metal carbonate into the acid. So 5 cm³ of calcium carbonate into a test tube containing 5 cm³ of colorless solution. And then you're going to flow the gas, deliver the gas, or bubble the gas into another test tube containing lime water. This is how we test carbon dioxide gas. If the lime water turns cloudy, that means the solution is an acid. Okay, so this is the chemical test, the procedure that they are going to ask you. So these are the types of explanation question. Basicity, the strength of the acid, strength of the alkali, and role of water. Got water or not? Got water, what happens? Got water can ionize into ion. No water, remain as molecule. Chemical test for acid. And now, this is the experiment part, okay? Preparing standard solution, method 1. Method 1, I always call it as the Milo method. Milo means how you make a cup of Milo. How you tapao Milo. When you go to Mamak, let's say you want to bungkus Milo ice ikat tepi, okay, this is what they will do. So this is the atas way of making Milo, bungkus Milo. So to make a cup of Milo, let me explain a few terms, okay? Standard solution. Standard solution means a solution with a known concentration. That means when I give you a solution, you are able to tell the exact concentration. Let's say a bottle like this in the lab that you see with a labeling. 1.0 mole per dm³. This is called a standard solution because there is a concentration. You can tell the exact concentration. If I pass you a cup of Milo, you do not know the concentration, then it is not a standard solution. Okay, let's see, what are the steps to make standard solution using method 1, the Milo method. So in order to make this Milo, there are 2 parameters that you have to obtain. Okay, you have to be very clear. of what is the two parameters before making this standard solution. So the two parameters are the mass of solute. That means today when you want to make a cup of Milo, you got to know how much Milo powder you have to use. And then the volume of distilled water. So these are the two important things in making a cup of Milo. How much Milo and how much water is going to decide whether your Milo tastes nice or not. So in the process one, what are we going to do? We are going to calculate the mass of solute. Okay, a solute. Different question can be a different example. Let's say in this case, sodium carbonate. In other question, it can be an NaOH. So first you got to calculate. So let's say they want you to prepare 250 cm cube of 1.0 mole per dm cube. So I told you that I want to tapao, okay, bungkus this solution, this amount and this concentration of Milo. So how are you going to start? First, you are going to calculate the amount of Milo powder needed, mass of Milo. How to calculate? By using mole equals to MV over 1000. Why this formula? Because they gave you volume and concentration. So you just sub it in. 1 times 250 divided 1000, you get 0.25 mole. And then how do you calculate the mass? Bring this mole over here, mass over molar mass. Let's say molar mass of sodium hydroxide, NaOH, and 16 plus 1, how much? 40. Okay, so it's 10 grams. So after you have calculated, by doing the calculation, they will give you 2 marks. And then the procedure is, after you calculated the mass, you got to weigh the mass of the Milo needed using electronic balance. So tell them what you do and then how you do it. So what I do is I weigh the mass. How I do it? Using electronic balance. And then this is what I do. So I got 10 grams of Milo here already. What do you do next? You add water. You add water into the Milo in a cup. Okay, this is how they make Milo teh ice ikat tepi. Okay, so they will make it in a cup first and then they pour it into a plastic bag, right? So you see, so they add water to dissolve the Milo. They stir it with the glass rod. So this is what you do next. After adding water, you stir the mixture with a glass rod until all the Milo is dissolved. So after all the Milo is dissolved, you're going to transfer it into a 250 cm cube volumetric flask. Always remember to mention the size of the volumetric flask. How do you know what kind of what are the size available? You just follow the question. If the question wants you to prepare this amount, then you just write the size of this amount, 250, by using a filter funnel. So I got my Milo in a cup now. I want to transfer it into a bottle. Okay, this is my very atas Milo. I don't put it into plastic bag. I put it into my special bottle. So I got to use a filter funnel to transfer it. After I put it into the bottle, I will rinse it with distilled water. I've rinsed the beaker, the glass rod, and the filter funnel with distilled water. Why? Because if you don't do this, you see, this is my cup. This is the Milo. After you transfer the Milo into the bottle, there will be some Milo stains. Okay, some maybe still 2 or 3 cm of Milo in the cup. So that's why you want to add water to wash it. And then the washing will be transferred into the bottle also. After you rinse it, you will transfer it into the volumetric flask also. So because of this step, because of you got to rinse it, this is why when you add water in the first place, you don't straight away add full amount. Because if you add full amount and then you rinse it, full amount 250 plus, let's say you use 100 cm3 to rinse, in the end it is going to become 350. Then it will be not accurate because I only want 250. Too much water can dilute my Milo, so I don't want to do this. Then what do you do next? Continue to add water until the meniscus level approaches the calibration mark. That means you are going to add water until meniscus level is this one, is near to the calibration mark. Where it is near, you will not use this bottle to add water anymore. You're going to change it to a dropper, and you add drop by drop until this meniscus level is exactly aligned on the calibration mark. So you see, add distilled water slowly until it is aligned. In the end, close the bottle, invert the volumetric flask. Invert means I will show you in the class, okay? Several times until a homogeneous solution is obtained. These are the points that you got to write down, okay? Nothing can be skipped here. Homogeneous solution means a nicely mixed solution. So this is how you bungkus a Milo into a bottle. So remember, first thing, mass of Milo is very important. After you got the mass, you just mix it with water. How much? It can be half of the total amount. Okay, let's say here 250, then you write 125 or 100 lah, around that. Next thing, after you pour two things together, you stir it with a glass rod. After you stir, after everything is dissolved, you transfer it into a volumetric flask. Remember to mention the size, okay, and then using a filter funnel. And then remember to rinse it, because some Milo is still in the cup. Rinse it. After you rinse it, you add water again, okay, until the calibration mark. Next thing, this add water includes add slowly with the bottle and dropper. Lastly, you close it and shake. By the way, inverting the bottle means, wait. Sorry, now 4 a.m. already. Okay, my brain is not working very well now. Okay, inverting means you do it this way, ding, 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 ding. Okay, inverting. Okay, then you'll get a homogeneous solution. Okay, so this is what I call the Milo method. Number 2, preparing solution with method 2. Method 2 is how to spell dilution. You cannot remember already. My brain is not working. 1L. Dilution, I think so. Okay. If I'm wrong, just sorry. Okay. Dilution, I call it as the Ribena method. Ribena means what? You have a bottle of concentrated Ribena. You want to dilute it. So you see, stock solution is your concentrated Ribena. Same thing, you want to make a cup of Ribena. It is very important to know how much stock solution. Stock solution means how much concentrated Ribena you have to add in to the cup with water. Okay. So same law, if you want to know, you go to calculate. Calculate the volume of the stock solution needed. How to calculate? Since this is dilution, we use the formula M1V1 equals to M2V2. So let's say this is our solution just now. I want to dilute this thing into 0.001 mole per dm cube. How do I do this dilution? I want this as my final concentration, so I put it into my M2, 0.001. Final volume, let's say I want it to be in this concentration, and I also want to drink the same amount, 250 cm cube. So my final volume will be 250. This one will be given in the exam, so don't worry. So what you got to know is the initial volume needed. How much Ribena you got to pour into the cup. So with the initial concentration, M1, 1.0. By the way, if you have any question, you all can text and ask me, because I also don't know what am I talking now. Okay, my eyes is closing actually. It's not okay. Continue. Okay. Okay. We calculate. So V1 0.001 times 250. 0.001 times 250 divided by 1. 0.25. 0.25 correct or not one? Wait a second. 1.0 mole, 0.01. Ayah. How come so better? Okay, actually it's correct one. Okay. So that means first, the amount of Ribena that I need. Okay, this is my first ball. This is my concentrated Ribena. I only need 0.25 cm cube out of 250. Okay, because I want to dilute it into 0.001. Let's say now I want it to be 0.5 mole per dm cube. I want to know how much do I need. So I do this M1V1. So initial concentration. I don't know how much is needed. Remember, volume will be given in the exam. They will tell you how much Ribena they want to drink. 250 times 0.5 divided by 1. In this case, you need 125 cm cube. You can see half of the volume of the Ribena. So after you have calculated the Ribena solution, you are going to transfer it straight away using a pipette. Same thing, into the bottle, the professional bottle. Mention the size using a pipette. So this is how they do it. Pipette. Okay. Go in. After pipette, what happened? What do you do next? Add water. Add water. Basically, 345 is the same as the last 3 points over here. Because Ribena, you got the correct amount of Ribena already, you just add water. Can Last part, calculation. In this chapter, got two main types of calculation question, like the one we mentioned just now, dilution. Dilution is M1V1 equals to M2V2. So there are 6 questions over here. Okay, pause and try the question. Okay, now I let you all pause. Pause 2 seconds for first 2 questions. Pause. 1, 2. 3 and 4. Pause. Sorry, 1, 2. 5 and 6, pause. 1, 2. Finish everything already. Now only you check the answer. Try. These are the answer. Sorry, I cannot do already. I'm very tired. If you can't get the answer, you ask your friend first lah. Your friend do not only you ask me. Hey. Thanks a lot. These are the answer. Usually people cannot get this answer for 5 and 6 because you forgot to minus the volume. Why need to minus if you don't understand? You ask me in the class. Sorry. I want to sleep already. Lastly, neutralization. The formula to calculate neutralization is MAVA over MBVB equals to A over B. M is concentration. V is volume. Everybody know this. What am I doing? A over B is the ratio from equation. That means you've got to do equation. Let's say example, HCl plus NaOH, you get NaCl plus H2O. Okay, A means acid. You see, this is a balanced equation. One HCl. So I put 1. How many NaOH? Also 1. Then the number will be 1, 1. Okay, so here, they can ask you to find either one of the 4 unknown. They can ask you to find MA. They can ask you to find VA. They can ask you to find MB. They can ask you to find VB. Same thing. Try the question. If you do not, ask your friend first. Okay, I show you question 1 and 2. You pause and then you do 1, 2. Okay. Question 3, 4. If my answer is wrong, please PM me. I also don't know whether I do it correctly now. Okay, can So this is for chapter 7, the explanation part, the calculation, and the experiment for standard solution. Calculation 2 formula, dilution M1V1 equals to M2V2. Neutralization MAVA over MBVB, A over B. So this is the short video for your Form 4 chapter 7. So remember to read your book as well, okay? Don't just watch this video and then assume that it is everything in this chapter. Okay, so just like that. Thank you for watching. Bye bye. Good night.